sequence and series. An arithmetic progression is such that the first term is -5, the last term is 135, and the sum of the progression is 975. So we are supposed to calculate the number of terms in the series. In this case, we first of all have to write this information down, that the first term is in fact -5, and then we have been given the last term as 135. The next information we have that the sum of these terms that we do not have is in fact 975. So what we are missing in this case is n, the sum of the terms, the number of terms. The number of terms is what we are looking for in this question. So when you have such an information, you discover that you do not have the common difference. We are supposed to use this formula that says the sum of terms is in fact n over 2, the number of terms, times a, which is the first term, then plus the last term. This is the formula that we are going to apply in this question. Now, let us substitute everything into this our formula and say that the sum is 975 is equals to the number of terms that we do not have. We multiply by -5 plus 135, which is our last term. This one will give us 975 is equals to the number of terms that we do not have. When we work out the bracket, it is going to give us in fact 130. So we multiply both sides by 2. We multiply by 2. This one will give us 100 and this is 1950. 1950 is equals to 130n. You divide both sides by 130. You divide both sides by 130. So this 130 and 130 will cancel. After they have cancelled, now we will have our n as 15. So the number of terms that can produce a sum of 975 is 15 terms. So 15 terms will give you the sum of 15 terms will give you 975. Let us proceed to the second part. We are supposed to work out the common difference of the progression. We need to note that for us to work out the last term, then we need to have the first term plus the number of terms, or the terms. We minus 1, then we multiply by the common difference. In this case, we have the first term and the last term. The last term is 135, and then the first term is -5 plus the number of terms we calculated, and it was 15. So the number of terms here, our n is 15. We minus 1, and then we multiply by the common difference that we do not have. So this is 135 plus 5 is equals to this is 14d. You divide both sides by 14. You divide both sides by 14. So this is 140 is equals to 14d. You divide here by 14. You divide on this side by 14 and on this other side by 14. So our common difference is 10. Our common difference is 10. If you want to prove, you go back to this formula, you substitute the d in this case, check whether you will have 135. So let us move to the last part, which is part C. It says that the sum of the first 3 terms of the geometric progression is 27. The sum is 27 and the first term is 36. Determine the common ratio and the value of the fourth term. In this case, let us say that these terms include a and then plus ar and then plus ar squared. This is the first term of a GP, the second term of a GP, and the third term of a GP, because they are saying the sum of the first three terms. In this case, we have used the three terms of a geometric progression. This one will give us 27. It will give us 27. The first term is 36. So our A in this case is 36. We substitute A with 36. So we have 36 plus 36r plus 36r squared is equals to 27. We put like terms together. 36r squared plus 36r is equals to 27 minus 36, which is negative 9. So we have 36r squared plus 36r is equals to negative 9. We want to remain with 1 on this other side, so we divide both sides by 36, by 36, by 36. In this case, we will have this will cancel, this will cancel, and this will cancel. R squared plus r is equals to, this is the same as negative 0.25. You discover that we are going to form a quadratic equation. So r squared plus r plus 0.25. We are going to use product, the product sum factor method to work out the value of r. The product is in fact 0.25 r squared. The sum is r, or 1r, and then the factors include 0.5 r and 0.5 r. So in this case, it is r squared plus 0.5 r, and then we close the bracket, and then we have 0.5 r plus 0.25. When you work this out, you will find that r plus 0.5 will give you this will give you r as